So now that we're done kind of talking about bonding structures, next we're going to talk about kind of some ways to shortcut drawing larger molecules. So drawing a Lewis structure like this, it's not terrible. We got 5 carbons with hydrogens on them. Every carbon's making 4 bonds. Every hydrogen's making 1. Kind of those things that help us out to know. But chemists, we like shortcuts. Our entire profession's built on shortcuts, it seems. So, you know, a Lewis dot structure, you know, maybe we actually have an oxygen in here. Let's make this an OH, because we need to have something with some lone pairs. Otherwise, the Kekule structure looks identical. So it's just like a Lewis structure. So we've talked about Lewis a lot. This is just no dots. And that's the difference. And so we've got our Lewis structure. All right, well, we're still gonna have 5 carbons, 1, 2, 3, 4, 5. We're gonna have an O and an H. We're gonna put our hydrogens in. We're still gonna show all the bonds. We're gonna show all the atoms. It's still a little tenuous to draw these. I've been doing this a while. It's about as fast as you can go, okay? Now condensed, we essentially go kind of carbon by carbon. So this is where we really start shortcutting, and they're really great for these carbon-based molecules because these can get very, very large. All right. And so our condensed, we just go carbon by carbon. So this is a C with 3 H's on it. So we go CH3. I've snuck this on you before in a worksheet. This formula, or this, not this formula, this format. This carbon's got 2 H's, CH2, 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 and then an O with an H. That's our chain. So that's our condensed formula. So it goes carbon by carbon. So what we are, you know, we are implying something. The less we have to write, the more we are implying. And so what we are implying is that there is a bond that goes from this carbon, and then this carbon bonds to that one, so on and so forth. And then these hydrogens are all bound to the previous carbon listed. And so essentially we are just breaking this up piece by piece and drawing it out. That's what we're doing. Boom, 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 boom. And oftentimes you consider this one group on the C when we get into the, or in one group on the carbon when we get into organic chemistry more later. But that's what we're doing with condensed. So we're not drawing the bonds, we are writing the formula in a way where it implies the structure. Now this is my favorite. You're gonna love how fast I draw this thing. All right, we got 5 carbons. All right, 1, 2, 3, 4, 5, and then I've got my OH up here. 2, 3, 4, 5. All right, that's it. That's all I have to do. Now, obviously, I drew that really fast. I was able to do that very quickly, which means I'm implying a lot with this structure. I'm not telling you, I'm implying. So, here's what a carbon skeleton does. It only shows carbon-carbon bonds. We don't even write the carbons. If there's just a change in direction, we're like, oh, there's a carbon there. And then if there's a carbon bonded to something else, we'll write the element at the end of the bond. And so what we have, we're hiding a lot here. So I'm gonna bust out some different colored inks. We have 3 hydrogens we're not showing. So we don't write hydrogens with their bonds because if we avoid that, we get out of a lot of the work. All right, there's 2 more here, there's 2 here, 2 there, 2 there. And then we also aren't writing the carbon. So at the end of a line, carbon. Change in direction, carbon, carbon, carbon. If it's not labeled, carbon. Right there, that's an oxygen because I wrote oxygen at the end of it. And then just by kind of convention, we do write an H with the oxygen to show that this is what we call an alcohol. You'll learn more about that in 223. And if you take OChem, you'll learn a whole lot more about that for a year. Well, you know, like 1 chapter of a year. All right, so that's what we're hiding here. All of that information, but you saw how fast I could write that. So guess what we like to use a lot for these large organic compounds? Carbon skeletons, because they get bigger than this. This is only 5 carbons. You know how many carbons are in a, you know, molecule that's in plastic? It's hundreds, if not thousands, of carbons long. Massive molecules. So like the cap on my pen, it's multiple molecules, but they're very big. And so they're long chains and they sort of entangle on each other. It's a spaghetti effect. is what one of my colleagues calls it. And they lock in place. All right, so kind of the key thing to know how to do here is just move between them. If I give you a carbon skeleton, could you give me the Lewis structure, vice versa? How do you know if you're looking at a Kekule structure? Well, there'll be no dots, there'll be no lone pair shown. That's why I had to sneak in the oxygen up here, otherwise they would look identical. Condensed structure, again, we don't write the dots. We're past the dots with these because we're trying to just get around writing as much as possible. So that's what we're doing there. And you know, if we're dealing with like double bonds, so we'll do another example here. Like let's say we have something like this. Okay, so we got a carbon double bonded to a carbon, and then we have over here, we have a carbon double bonded to an oxygen, single bond in the middle. So this carbon is making 1, 2, 3, 4 bonds. 1, 2, 3, 4, okay, we're good. And then, oh, this is still my Lewis dot, so I gotta put the dots in. All right, so my Kekule, identical. I just don't write the dots, right? So C double bond C, single bond C, double bond O, and I just bring my hydrogens back in. There you go, it's like Bob Ross, happy little hydrogens, right? You make little happy little hydrogens all over the place. Well, not so much with carbon skeleton. All right, so our condensed, well, what do I got here? I got a carbon with 2 hydrogens. So I go CH2, I got a carbon with 1 hydrogen, CH, another one with 1 hydrogen, CH, and then I have, oh, I'll make that look cleaner. We have an oxygen on the end here. Or, you know, you're like, how do you know there's a double bond in there? Well, you have to look for the missing hydrogens. We can also just write the double bond in still. You might see it either way. So sometimes we draw the double bonds in condensed, sometimes we don't, just depends on how lazy we're feeling. A lot of this had to do with the fact that this was very easy to do on a typewriter, and so that's what we would do. And so you just kind of like write it out. There's a system with parentheses for branches and stuff, but we're not going to worry about that right now. And then the carbon skeleton. No more happy little hydrogens. All right, I've got carbon double bonded to a carbon, single bonded, double bonded oxygen. So there's my carbon-carbon double bond. So for a double bond, we just draw a double line. We got a carbon here, we got a carbon there, double bonded to an oxygen. So that's our double bond. And you'll never guess what we do for a triple bond. That's right, we just do 3 lines. Aside there. So that's what I really wanted to show, is how we deal with double bonds, triple bonds in these line structures. And it's the same way we deal with them in the Lewis structures. We just draw double and triple bonds. All right, so that's kind of the different formats we're going to talk about in this class. I'll have a practice worksheet up, and you know, you'll go working through backwards and forwards through all of these. All right, so we'll leave it there. And we've got one more topic left in this chapter, molecular orbital theory, and so that's what we'll talk about next.